Hi guys, I hope you are fine. You've chosen the topic optimizing web applications for performance for this month's workshop. So we have quite a lot to cover. And before we begin, I would like to mention that this topic is not exactly workshop friendly in terms of demo code and practical examples, because for actual bottlenecks and actual problems in a web application, we will need to have a very heavy solution, production database with millions of records, and that's pretty hard to obtain for a demo. Nevertheless, we're going to cover quite a lot. I'm going to share with you all my experience with web application optimization. I'm going to share with you what kind of problems you may hit, how to analyze them, how to find different little aspects of your application, and I'm going to cover both backend and front-end optimization. I'm going to use a sample project to show you different concepts throughout the code, and I'm going to use one of the production websites we're using in my current company to show you different kinds of concepts you may want to utilize in your own web applications. So first we're going to start with backend optimizations. The whole presentation consists of just a list with different kind of bottlenecks you will find in your application. I tried to cover everything possible, and I'm going to give you different examples from my experience and my uh, bottlenecks I used to fix in my previous jobs and my previous projects. Also, I'm going to give you some tools which you can use to optimize parts of the application, but keep in mind that the whole process of finding bottlenecks and optimizing is cannot be written as an algorithm, as a step-by-step plan. Do this, then that, and your app will be optimized. Because usually optimization is uh, very specific to the application you're trying to build. It's very specific to the database you have designed. It's very specific to the infrastructure you're using. It's super specific, but for your typical average web application, no matter how many users are using it, I'm going to give you a lot of tips how to improve the performance. I had a website which loaded for like 6 to 7 seconds, and after all the tips I'm going to show you today, it started loading for less than a second, and that's a huge improvement. And I did it for like 3 days, maybe even less. It didn't took me too too much effort, and didn't took me a lot of time. So now we're going to see what I'm talking about. First, how to find any problem in your web application, because usually you will receive a ticket from some of your customers. For example, the app is not loading, I have a problem, blah blah blah. That's normal, but usually it's not because of the app. Usually it's from the user, from his internet, from a second which the database was not available, and so on. But when you analyze the problem, you will find that maybe your app is lagging, maybe your app is not using all of the resources available, maybe there's a problem. How to analyze that? First things first, you need to refresh your site, of course, and see that something is not quite right on your production environment, on your staging environment, on whatever. But how to analyze what exactly is falling? how to analyze what is not working, what's the problem, and so on. I'm going to use softuni.org, one of the sites we're currently developing. It's about training, making programmers. It has a lot of courses, webinars, and so on. The site is working fine, in my opinion. It's quite fast, but nevertheless, sometimes we may experience some sort of a problem because bottlenecks usually occur in not during development. Not during development, you deploy a new feature, everything is working fine, and 6 months later, something starts lagging because a lot more users were accumulated in the site, a lot more data was written in the software. You, and as the application grows and as the application becomes more feature heavy, more user heavy, we will start seeing a lot of performance issues here and there. The golden rule of performance optimization is not to do it prematurely. Never optimize because you've read somewhere that putting an index in the database for these columns will improve your performance. That may be true. If you put the index, that may be completely correct. That's not a problem. The problem is that you're making your application more complex by introducing different kinds of optimizations earlier. For example, you're introducing caches, you're introducing indexes, you're introducing, for example, microservices architecture. All of these optimizations costs you a lot of development time because of the increased complexity. Your app will become more complex. You will have more code which you need to maintain. You will have more infrastructure which you need to support, and you are going to make your application more expensive than it actually needs to be. So never add these rules and these tips I'm going to give you today without actually finding that you have a bottleneck, without actually seeing that something is not right and the app is very, very, very unresponsive. Also, keep in mind that from time to time, you may have a huge peak of users and the app may start working irresponsible then. But that may not be, again, a reason to optimize it. Because if your app is not responsive, but that happens only for 2 minutes and during the whole month, that may not be crucial for your business. So in order to optimize, you need to be sure that your app is not responding correctly almost every time. There is no external factor, for example, internet, for example, the web server you're using was updating, and all other kinds of situations you may find yourself into. So the golden rule is never optimize prematurely. You need to be sure that you have a bottleneck problem. You need to be sure that there's a real issue and that a lot of people are complaining that something is low. A lot of people, maybe your end users, maybe your administration team, maybe your marketing team, it doesn't matter. But don't optimize prematurely. Don't introduce extra complexity to your database, to your web application, to your infrastructure, and so on. So never introduce any of these tips without thinking about it first. Really, the additional complexity is not worth it, for real. So, okay, let's say that this app is loading fast enough, except for example this portion here. We see that the webinars are taking 5 seconds to load, and 5 seconds are quite a lot actually, even if everything else on the website loads correctly. This situation is easy to find because you see that some part of your project is not working correctly and you decide to see what's going on. But another tool you can use is the Chrome Inspector itself. You can open Developer Tools and go to the Network tab. There's a Performance tab here, which allows you to hit Record, refresh the page, wait for it to load, and then hit Stop. Wait a little bit, and this Performance tab will give you a lot of data, but it will be more about the JavaScript code you are running. So let's say that this is too advanced, especially for normal optimization. So I suggest you don't use this performance tool unless you need to find something very specific, because this is quite advanced. It's very heavily it has a lot of data in it, and it shows every single function in your JavaScript code, and it's more difficult to analyze the data. So what I can suggest is to use the Network tab instead. And the Network tab allows you to capture every single request on your web page, because your web page has an HTML file, which should be fast enough. Then it has some rendering on that HTML, then it finds some links, then it has some styles, then it has some JavaScript code, and so on and so on. So the most important thing you need to do here, if you don't want to debug your code but want to see the performance of your app, is this last column called waterfall. When you refresh the page, sometimes it's a little bit buggy, so I'm going to close it, reopen it again, refresh the page, open the Network tab, and now it's showing correct data. So here are all the requests made in order to load this page right here. This includes a lot of API calls, JavaScript calls, CSS calls, images, and so on. So if you go and analyze the waterfall, again, I need to refresh it because I made an AJAX request. If you analyze the waterfall, you will see what requests are slow, or at least slower than the usual amount of time. For example, this request layout CSS was super fast. You can hover on every single request and see how many seconds it needed in order to be loaded. For example, I can see that we have 0.11 microseconds. So this Wogo header SVG is quite fast, so it's not a problem. It shouldn't be optimized. That's super fast. But then I can see that I have a request which takes 30 milliseconds. Considering that the total amount of the page was 1.5 seconds, this is quite a lot. It's fast enough, so I don't care, but I can see that I eventually may have to improve that. I can see that all of these calls here are essentially slower than anything else on my page. I can literally see every single web request made to my server or to external API or to a content delivery network, but I can see which requests are essentially slow. And if I want to optimize this page, for example, this page may load for 5 seconds. If it loads for 5 seconds, and I'm not quite sure why, because a lot of data is loading at the same time, I can see this Network tab and analyze the response times here. So if I want to optimize further this web page, I can go to this tab and see that this request is for some reason slower than anything else. So I can go to the server and see API LMS open course instances, get all limit 2, and see what's going on there. Of course, I can analyze all the requests here. If you have a performance bottleneck, which is visible to the naked eye, here you will have something that loads quite a lot of time. Uh, Something else, because I said naked eye, never measure only the end result and never think about performance in terms of numbers. What I mean is that if you have a website which loads for example 0.001 second, that's quite a fast site, and if you have the same website optimized to load for 0.01 seconds, in terms of performance I have 10 times better performance. 10 times is huge. If you tell somebody, hey man, I improved the performance of my site for and now it's 10 times faster, he will be like, wow, what did you do? That's a huge increase. And of course, 10 times alone sounds super. But in terms of practical performance, both sites are super fast because our eye can transform visual data to a certain extent. It doesn't matter whether something is 0.0001 seconds or 0.001 seconds. That's 100 times better, but still both are super fast in terms of practicality, in terms of the human usability, the human usability of the site. So never measure performance in terms of numbers only. Measure it whether it's okayish for the user to use the site or something is super slow for him and he's getting impatient. And for this situation right here, if somebody tells me, hey man, I improved that and now it's this, I'm going to say, well man, you lost your time, you wasted it, because he didn't have to invest one day to improve this to this. It doesn't matter. Nobody's going to notice it. So never optimize prematurely and never optimize based on your feeling. No, don't optimize because you think that you can improve the performance of something without first having the actual performance bottleneck. That's super important because of the complexity, because of the wasted time, and so on. So let's say that we investigated our site, we are kind of not satisfied with its performance. Currently, I'm satisfied with the performance of this site. It loads quite fast, so I'm not going to optimize. But let's say that we see that the open courses panel is not loading super fast, especially comparing it to the webinars or to the blog. Or let's say that the menu here is loading a little bit slow. Let's say that something else is not loading correctly, and I can easily analyze that by using the network tab I showed you earlier. And that's completely okay. So I find something that it's not very good in terms of performance and I want to improve it, and I have the reason to improve it because either somebody complains or I can see that it's very slow. And usually you want to try that on your production site. You want to have a real user reporting the issue because on the development machine everything runs fast enough. Nothing is a bottleneck because your data is fake data. You don't have millions of records locally, probably. You don't have a lot of users concurrently trying to access your site. So the production is should be considered every time you want to optimize something. Never optimize based on your feelings or based on your development machine, because development machines are usually also super slow compared to a production server. A production server may have more than 200 gigabytes of RAM. No development machine has that kind of memory. Your production machine may have a lot of CPUs and you may have a normal machine which is fine for gaming, fine for development, but not fine for a server environment. So never. Always consider every single aspect of your application before trying to optimize it. Usually the optimization problems come from your team leader, from your client. In terms of softtuning.org, the client is our CEO because he checks the site, he decides what is good, what is bad, and so on. But usually the problem comes from your client. So let's say we understand that there's a problem with some of our sections. For example, the section with the webinars. The webinars are not loading correct. I saw the request. I saw that the URL was /API/LMS/open course instances, whatever. And then I need to understand what is slow, because it may be slow because first, but that's not very likely, it may be slow because the front end has some logic which is not executing fast enough. That may be the case, but the front-end optimization is more like micro optimization. If we have something that is slowing down in 5 seconds, usually it's not the front end. So we need to search in the backend. I'm going to cover the front-end micro optimizations later. So the backend optimization may be usually it's the database. But sometimes it may be an algorithm or a logic we have introduced in our code. But first we need to start with the database. The database may have a poor design, or at least a design that was working correctly in, for example, 1 year ago. But nowadays, with our current usage, with our current request load, with our current data, it may be poor and it may be changed. I'm going to give you an example how come a database design is good enough at one point and then it starts to be kind of not okay. We have a judge system in our training center which allows us to execute code, automatic exams. Students send a piece of code, we automatically run it, assert it through some tests, and then return our result. So that system was working fine for like 4 or 5 years. The database design was great, the web app was great, and the system served its purpose perfectly. But from one point onwards, the when the user submitted a record, the database started slowing down, and we noticed that the web app took like 5 to 10 seconds to receive a response, which usually needed like maximum 1 second or so. So we decided to investigate, and we saw that one of our tables was having more than 6 million records. And in terms of database, that table was great when we had like 1 million records, 2 million records, but at one point it became too slow for the operations we needed to do. So what we decided to do is we analyzed the business requirements for that table, and we saw that most of the data which is needed during exams is actually the newest data. So the data for the last month or so. So the whole database was filled with 6 million records, and we only needed like 500,000 of them. The result was we extracted a lot of that data to a separate table which we called an archive, and changed the code that every time a user needed to access data which is newer, for example for the last 6 months, we used the original table. But when the user wanted to see something from the past, for example, 3 years ago, we said, okay, then you are going to call the archived table. We're going to write a message on the web app saying, hey, you are using you're using old data. You need to wait a little bit longer before we can return it to you. So we apologize to the user, and the user is completely fine with that solution, because when he checks with older data, he is completely fine to wait a little bit more, because the older data is not a real-time exam. So we changed our database design, changed our code to use the new design, and we improved the performance. And we also added a background job to find all the old data which is starting to pile up and to transfer it to the archive table. So we changed the database design, and now our app is fast enough and it's working okay-ish. So the first problem may be poor database design, but that requires a lot of effort to improve the performance. You need to change the database, you need to migrate data, you need to change your codes. That should be your last resort. Poor database design should be your last resort. What is important in terms of database design is never make too many tables which require a lot of joining. So never do object-oriented style tables, never do inheritance, never do some sort of table splitting. For example, if you have a super simple example, if you have an animal, and if you have a cat, a dog, and a bunny in your application, if you're doing that in terms of object-oriented design, you're going to say, okay, one animal class, one cat class, one dog class, and one bunny class. The last three are going to inherit the animal, and that's completely fine. But in terms of database, that will be too much, because every time you fetch cats, you need to join the animals table every single time because of the inheritance. Every time you fetch dogs from the table, you're going to fetch and join the animal table too. And that's completely unnecessary. That's all that joining is adding additional overhead. So the better solution here is to have an inheritance in your code to follow best practices in terms of object-oriented design, but the database should have only one table, animals. And when we want to get only the cats, we are going to filter through all the animals which are marked as cats. That's faster than joining two tables every single time. So in terms of database design, the rules are never follow object-oriented design for your tables. Make sure you design your tables based on your queries and based on not repeating data, and not because animals are the base class of the cats, because that's a mistake I've seen in so many projects, which then suffer from performance issues, and it's very difficult to migrate a huge hierarchy of tables. So prefer a single table which can filter through all the inherited tables. That's the better approach. And if we already made the mistake, make sure you try first to optimize in some of the other ways I'm going to show you before redesigning the whole database. As for the judge app we had, that was necessary because we applied indexing. We couldn't use caching techniques because the data was almost real time, so no cache here. and we couldn't improve the code logic because the code logic was super simple. Insert a table row and fetch a table row, which cannot be optimized. So our problem was having a poor database design for the current data we had. The second thing you may consider is if you have a problem with this part of your website, you may have a problem with the query itself. So you can get the query which you are using for your database. You can go to a profiler or you can go to SQL Server and see the execution plan of your SQL query. So what is execution plan? If you don't know that, I already posted videos about database indexes, so I'm not going to cover them in this video. Make sure to check these two videos out about execution plans. They are available on my Patreon, and about indexes. So if you have a slow SQL query, just run the query on your SQL Server, see the execution plan. For example, if I have this table, you may have some filtering, it doesn't matter. You can run the query which your application is using. You can include the actual execution plan, and going here you can see what happens with your query. I'm not going to cover everything involved here about indexing, what is a scan, what is a seek, what is an how to see what can be improved, because I already covered that in one of the videos on my Patreon feed, but this can really help you to analyze your queries. So the solution here is to consider adding an index. For example, if you're constantly searching for is deleted equals 0, something like that. Is deleted is a column which marks an entity for deletion, and if you're constantly searching for is deleted equals 0, so because that's the normal flow of your application, you're not searching for deleted entries, consider adding an index on that. Consider adding an index on every column you're constantly using in your table to read data. This may improve your database performance up to 10 times. But again, you need to know about indexing, and I covered everything you need to know about indexing in the videos on my Patreon feed, so I'm not going to get into more details about it. So one of the problems may be that your query is slow. If the query is slow, the solution is adding indexes. Or if adding indexes doesn't solve anything, it may be the poor database design. But let's say that the design is okay, and let's say that the query is a little bit slow. If you add indexes and it starts working correctly, fine, you leave it like this. Then the next problem you may have is that you may have too much data in your database. With too much data in your database, you have a lot of options to consider. The first is the solution I already told you. You may archive the outdated data which is rarely used, or you may archive the deleted data. For example, if you have 5 million records and more than 3 million records are already deleted, we are talking about a soft delete, a delete in which we only mark the entity as deleted, then you have 2 million actual records you're using actually by your web app, and 3 million deleted records which can be used in terms of reporting or statistics, but are not used every day. So if that's the case, you can archive all the deleted entries in a separate table. This will allow you to have only the data that is actually important for your app available and nothing else. You can also do a cache table, which is a separate table with pre-cached values. You can also do stored procedures. You can try different kinds of options, but I suggest that you never use stored procedures unless completely necessary, and never use cache tables unless they make perfect sense and you cannot optimize anything else. Not that these two approaches, cache tables and uh, stored procedures, not that they don't improve performance. They're great in terms of performance, but they add additional complexity. They split your business logic in your code and in your database, and debugging becomes harder, uh, maintaining becomes harder, bug fixing becomes harder. So you're going to make a lot more expenses in the future in terms of development when you can improve your code or just invest in new hardware. So never consider stored procedures as your first option. They may be great, but they add a lot of complexity. A lot of complexity. You need to maintain two separate languages. For example, if your app is in C Sharp, you need to maintain Transact SQL and C Sharp, and debugging is super awful. So uh, in terms of database, try to use more techniques that are more easy to implement. For example, a separate table which is used as an archive, an index, something that is very easy to implement and very easy to see whether it will work or not. Because if you move a lot of your business logic from your code to a stored procedure, it may take you 12 days, for example, and finally you may find that this will improve only 0.1% of the problem, which it's not worth it. So always try your easiest solutions before considering optimizing with a more complex way. We always should prefer less complexity in our code rather than more complexity and more performance. The next problem we may have is slow object relational mapper operation. So how to notice that? If your code is using mainly uh, entity framework, for example, or Dapper or something like that, which is an abstract code for writing queries, and let's say that we have something more difficult. For example, this query, which has a filter, has an order, and has a select which maps to some columns here. So that query is a little bit of more complicated, and let's say that we um, see that this is the slow part of our application. This is what we need to improve. This is the slow query. How to analyze it? Well, what we need to do is we can put a SQL profiler, which comes with every database. We have a profiler which shows every single query that runs on our database. So we can hit this endpoint, run the query through our code, and we will see the actual query generated by our object relational mapper. And we can copy paste that query and run it in our database directly. For example, we will see that we have a filter on the user ID, we have order by on the published on, and we have some select statement. And we can then analyze what is going on. We can run the execution plan and decide what to do. We can add an index on the published on property because that will improve the sorting, and most of the time sorting is very expensive operation, and adding an index will store the sorted data before we run the query, so it will be already sorted when we try to run the query. And if we have an index on the user ID, that will be more than enough to improve the query. From now on, it may that improvement alone may not be enough if we have a lot of data or something else is going on. So when we use an ORM, we can see whether the ORM is generating a good query. First things first, we need to see whether the query is super complex, and if it's too complex, we may think of a better way to improve the query, because sometimes ORMs don't know exactly what we want to do and try to guess. They return correct results, but they don't write optimized queries. So if that's the case, we can change the ORM settings. That's the first option we may try. For example, untracked entities in read-only queries, or for example, disabling change trackers, or whatever options our ORM provides us. I have a very good series about Entity Framework performance. It's on my YouTube channel, so make sure to check it out if you haven't already. You will understand a lot of concepts behind the ORMs, so make sure to get that. You will understand how to improve Entity Framework, you will understand how to write better queries, and so on. So I'm not going to cover every nitty-gritty detail about Entity Framework Core, because you may use another ORM which may have different settings, for example, and Hibernate. So you may consider rewriting the query to a SQL query and make your application run the query. And if it's still slow, then we have this problem, which is analyzing the execution plan. But sometimes you may not be using the ORM correctly. ORMs are very cool because they provide you a fast way to code a database, but they also give you a lot of magic behind the scenes. And when people and developers don't understand that magic, they tend to write queries that do not perform well. So if you use ORM, make sure you understand how your ORM works, make sure you understand how that ORM translates your code to queries, and make sure you understand all your ORM settings to make it as optimal for your situation as possible. So a rule of thumb here is learn the ORM. You can watch my series about Entity Framework Core if you're using Entity Framework Core, or the old Entity Framework. I covered it too. The last thing you may consider is to use precompiled queries or DB context pooling. These two options are available, for example, in Entity Framework Core. The precompiled queries allow you to run the queries once. These queries will be cached by your ORM, and then they will be super fast, at least in terms of the ORM. If the query itself, the SQL itself, is super slow, then you again need to analyze the execution plan. So you may consider precompiled queries. They may improve the performance of your app up to like 5 times. 5 times is a lot. But if the issue is in the ORM itself, if the bottleneck is in the ORM itself, then precompiled queries may be good enough for you. But if the issue is in the SQL query, then the ORM may not be the problem. You need to analyze the execution plan and add indexes. But I had a huge success with precompiled queries, so always consider them. As you can see, I'm suggesting easy to use solutions. To make a query precompiled in your ORM takes like 15 minutes. So with 15 minutes you can see whether you improve the performance or not. Then if that's not the problem, you may analyze the ORM settings. All of these take like 5 minutes to check, and you can again see that the ORM is not the problem, or it's the problem, and then leave the settings changed. But if the ORM is not the problem, then you can check the SQL query. And adding indexes is also super fast, because when you add an index and run the query again, you can see the performance improvement. You can see the execution plan, you can see the execution time, you can see everything. And the last thing you may try is DB context polling, but that's only if you run the execution plan and saw that actually the SQL query is fast. Then you saw that the ORM operations are also fast, that the precompiled queries is not improving anything. You may try DB context polling. DB context polling reuses the DB contexts created by Entity Framework, and they improve the performance on scale. This is more difficult to test. You need to have a lot of concurrent users to test whether the DB context polling is an option for you. But let's say that this should be rare. The most problematic areas of your application will be the query which your ORM generates, or the SQL query itself. So if the query is not generated okay, rewrite it to a native SQL. And if the native SQL or the generated query is slow on your database, then you can try indexes. If indexes fail, then you try to analyze the data you are using. Rarely used data can be extracted to a separate table, which will improve your app a lot. Data that is outdated, data that is not used very often, all of these can be extracted, but never do it prematurely. Again, never do it prematurely, because your database and the way you use your database may be completely okay even for tens of millions of records. So in some cases, 2 million records and particular queries may start become slowing and slowing and slowing and until it's not usable anymore. But in some situations you may have 100 million records and your queries may run smoothly. So you need to check where exactly the performance problem is coming from. Good, we covered the ORM, the queries, and the database design. Next, we need to cover if a query is fast enough. You test it locally, you test it on your machine, you test it on the production database, and the query is working fast. But a lot of users are complaining that this particular feature of your website is not working. You try the queries, you see that everything is running smooth. Then you have the problem that the query run alone is super fast, but when you have a lot of users using it concurrently, then you have a problem. So a possible solution here is not to improve the database design, not to improve the SQL query, not to improve the ORM, but to cache the results. I'm going to talk about caching after a short break of 5 minutes. So we're going to continue in 5 minutes. I'm going to be back when the counter hits 5. Okay, let's continue. Before I talk about caching, I'm going to show you the Entity Framework series. Go to my channel, mytestsp.net TV, playlists, and here you can find Entity Framework performance tips. I believe the whole playlist is about 2 or 3 hours, and I cover everything you need to know about Entity Framework and Entity Framework Core so that you can use it correctly and you can use it as optimized in an as optimized way as possible. Good, so now let's return to the problem when our queries are fast when we run them individually, when we run them in an isolated environment, but when we see performance issues while a lot of users are trying to hit that query concurrently. Because every time you call a database and you call, for example, every time you call a request like this one here, your browser needs to call the server needs to call the database, and that's some sort of network related performance that you can improve. Calling the database requires a network call. Then the database needs to aggregate the data, needs to return it to the memory of the server, and then that memory needs to be streamed back to the client. So what we can improve is we can improve a lot of our application by simply caching it. How to cache it, because a lot of people know that there are Redis caches, in-memory caches, various other caches, but first things first, you need to consider whether caching is suitable for this operation. How to analyze what's cacheable and what's not. For example, the whole idea behind the cache is the question: how many times a day, a month, a year, a certain period of time does my data change? How many times? That's the whole question you need to answer. For example, the trainings here are coming from the database. All these courses are coming from the database because they are dynamically changed from the administration. And every single person who hits the landing page of this site, every single person, which during marketing campaigns maybe tens of thousands of people who hit the website, every single person is going to ask the database, hey, what are the current active modules or upcoming modules? Hey, what are the current open courses? Hey, what are the current webinars? So every single person will call the database if we don't have any cache involved. And that means that if we have 10,000 users, the database will be called 10,000 times for the same result, which is unnecessary. Because in terms of our business, trainings are added, let's say every month. Every month we add new trainings. So, and every month we add 2 webinars. Let's say that this is the case, or 20 webinars. Every day we add a new webinar. Every day we add a new blog post. Every day, not every second. Every day we add a new open course. So if we change the data every day, only once per day, then there is no point for 1,000 users to ask for the same data 10,000 times a day. It doesn't make sense. So what we can do is we can improve that by adding a cache. Adding a cache means that we store the results from the database somewhere and don't call the database unless we delete the results. So what we can do, we can cache the upcoming modules and we can save these trainings in the memory of our server. We can cache the open courses here, we can cache the webinars, and this technique will improve the performance of our site. It may improve it up to 10 times. It has a huge impact because we are saving the database network call and we are saving the database queries. That's a lot to consider, especially when we have a lot of users involved in the website. So we need to consider the data, whether the data is frequently changed. If it's frequently changed, then caching is not an option. Then we need to try something else. But if the data is changed once per day, we can easily cache the data for a day or for 1 hour. Even if we update it every single hour, then it's completely okay. And that will improve the performance of this website. So if we cache the open courses because they are changed once per day, if we cache all our webinars and all our blog posts, these data calls will be saved, and that's a lot considering the scale of the app. The trainings too. So the whole landing page, the whole home page will load without calling the database, and that's a huge improvement. You can cache everything which involves a lot of users at the same time. All the landing pages have these characteristics. All the landing pages which the marketing team sends the user to them, because usually these pages are the most used by the end users, and we can consider caching everything which we can. For example, these testimonials here can be cached. If this is coming from the database, this can be cached, because how often an institution receives an award? 5 times per year, maybe. So we can cache that. How often do we change the trainings? Once per day. Even that's too much for an institution, but nevertheless, if it's once per day, then we can cache that. So caching is a super simple tool we can do, and we can utilize in our application. What kinds of caching we can use? First, we can use an in-memory cache. This means store the data directly on the server. ASP.NET Core provides a very easy iMemory cache service. iMemory cache service, something like this. We can introduce it here, and then we can use, for example, every time somebody tries to fetch OIDs, we can cache it. We can just say the cache is like a dictionary. It has create entry, remove, try to get value, or get or create, for example, is a good way to use the memory cache. We can say, okay, cache the data with some key, my key, and then I can say something like this, and I can return that. Get or create cannot be returned. Let me see how we can use that, because it should return the item. Yeah, okay. So I'm going to say enumerable from int. Good. Return that. Then return that. And what's also the problem? Yeah, okay. These tasks are having some the most simplest way, because I don't want to lose time seeing what the tasks require, is this cache try get enumerable var entry is try get this enumerable from int with some key, my key, like this. This will try to get the data from the cache. Then we can say if entry equals no, then the cache doesn't have that data available, it wasn't stored. Then we will say, okay, get the data equals that, and then we're going to say cache create entry set entry set my key. Then we're going to say data like this, and we can even provide some options. For example, when the data should expire, and we can say date time offset something like 1 day. We can say it like this. So what we consider here is get the data from the cache. If it's not available, get it from the database, and then set that data into the cache and retire the data, delete it from a cache in 1 day. Or you can add a minute or whatever works. It doesn't matter, but the important thing is that all cache providers should work like this. We try to get the data from the cache with some key. It's essentially like a dictionary. If the data is not existing, then get it from the database and set it. Different caches have different kinds of options. For example, you have absolute and sliding expiration. Depending on the business case, you may decide to use either absolute or sliding. Sliding means that if nobody tries to fetch the data from the cache, it will be deleted. Otherwise, the timer will be restored. So if you say a sliding expiration 5 minutes, this means that if for 5 minutes nobody tries to get that data, it will be deleted. But if somebody tries to get it, then another 5 minutes will be waited. And an absolute expiration means that you can specify an exact time when this data will be deleted from the cache. You can also specify different options like cache priority, whether or if the memory of the server is is getting full, what to delete first. The entries with highest priority will be deleted last. This is the way you can use caches. The first approach you can do is use the iMemory cache provided here. Keep in mind that if you have parameters like paging, like other options, for example, public only, you need to cache for each page. You may decide to cache only the first page, and if the user hits the second page, then that should not be coming from the cache, and so on. It depends on the business scenarios, but always consider the parameters, because these parameters return different results from the database, so you need to consider them. For example, if I want to cache that here, I can say if page is 1, then use cache. The same way I used it here. Otherwise, run the database query as normal. That's important because usually the first page is something that a lot of users will hit, but the second page, not that likely. So for the second page, you may decide to not cache it at all. It depends on the business case. My advice is cache everything which is on the landing page, like these trainings here, like these open courses, webinars, blog. Cache everything which is on the landing page and which does not change frequently. What to do with data which happens to change frequently? For example, these statistics. If these statistics are live, and every single student is written here as he registers on the site, then you may need to talk to the business owner whether these statistics are super important. It's better to have cached statistics which update for every 5 minutes than to have a database call on every single landing page view. Keep in mind that in very highly scalable applications, for example, applications which have hundreds of thousands of users every minute, that's huge scale, of course, even a single cache for 1 minute will improve and will make a difference. So don't think about caching as something which should be introduced only for data that changes rarely. Don't think about that. Think about how many database calls I will save if I cache. And if you have 10,000 of users every minute, even if the data is changing frequently, you may still cache it, for example, for 10 seconds. You will save 1000 hits to the database, and that's a lot of improvement. So even a cache for 10 seconds may improve your application. So consider small caches too, caches which change frequently. But if you have a huge load, that will be a huge improvement. So consider even caches for a 1 minute. If you have a lot of users for that minute, you will save a lot of database calls. Be careful with data updates in this situation, because you will have a lot of, if you need to change the data, make sure to invalidate the cache. Make sure you delete the cache entries. That's important. If, for example, the administrator of the database of the application changes a data, make sure you update the data in the cache too. This is what I meant when I said that adding infrastructure adds complexity, because when you add a cache, now you need to think about every single time somebody updates the data in the cache, and that's additional development time, additional development resources. You need to implement the code for invalidating caching, and so on and so on. So never introduce a cache without seeing a problem first. You don't need it. Also, you may think that you need a cache, but then the website may be fast enough. So never think about optimization prematurely. If a memory cache is not enough, you may start using Redis as an external server, but that adds also additional complexity because now your infrastructure changes. You need to support the infrastructure, you need to deploy it, you need to support the networking to that infrastructure. So make sure you try all the simple ways first, the in-memory cache, and then if you see that you need a bigger cache, something that's more reliable or something that uh, has more features, then start using another provider like Redis. So in terms of caching, I want to summarize. Caching should be done when you analyze everything else and everything else seems to work fine individually, but on scale it doesn't work. Cache all the data on landing pages which does not change frequently. And remember that even if it changes frequently, if you are working on a high scale, you can add a cache for a very small amount of time. Even 30 seconds can make a difference. Next, your bottleneck may be something in your code. Bottleneck in your code, considering that we're doing an ASP.NET Core project or a server project, you may have a blocking operation. Blocking operation is bad for your server code because servers are asynchronous by nature. Never use task.wait, task.result, for example, like this, .result. These are blocking operations. Always use async await or don't use blocking code, because blocking stops the current thread from responding, and the current thread is using a CPU, and you may very easily make a lot of blocking threads which are using resources, and this means that next requests will need to wait for this blocking request to finish before they can use resources, and you will starve your server. So never use blocking operations. If you need to use a blocking operation, consider refactoring it or consider extracting it as a background job. I'm going to talk about that in a minute. So blocking operations are when you are using async await. If you say something like thread sleep or task wait, everything that involves tasks and is not awaited, and you are waiting for a result but not using the await keyword, you are blocking, and that's a problem because you are not using your cores and processors optimally, so you may have a performance problem. A very simple but not very known issue is returning enumerables from actions. This blocks the serializer. Always use toList or toList async before returning these enumerables. Like here, I'm always toListing before returning data from my actions. I'm always using a toList or first or default or any. I'm always using some sort of a method which gets the data from the database. Don't use enumerable directly, don't return it in your ASP.NET Core code because you are blocking the serializer and you will starve your web server for resources. Another problem besides blocking operations is too many network round trips. Try to fetch all the data you need in a single call or 2-3 calls maximum. Do not fetch a lot of prefer joins prefer to make database joins compared to multiple calls. That is the main rule, but there are exceptions. Sometimes joining may be too expensive, but you need to measure that. Sometimes calling the database 3 times is better than calling it once with a join. So make sure you measure both scenarios to understand which one is better for your application and for your performance problems. But that's not a big deal, except if you have tens calls in your servers. Blocking operations are more trickier and more problematic than multiple network round trips. Always try to not block when you read from files, you read from databases. Always try to use async await. This way you're going to use CPUs as optimally as possible. Now, these are the most common problems you have in your backend. When to optimize, when to optimize, I already said it, when you hit a problem. But the hot path is something that is important for your application. The hot path is the most used features. The most used features should be optimized. All the other features may not be that big of a priority. I forgot to tell you about response caching. Response caching is an attribute which allows you to add a response cache, for example, for 30 seconds, duration 30 seconds, or something like that. But keep in mind the following. Response cache caches the whole logic here. Response cache caches the whole action. So it caches the returned HTML, it caches everything. And response cache cannot be used when you have authentication, for example, because the same URL will return the same data for different users, which is not okay. And if you use response cache with logged in user John, then Peter will see John's data because of the response cache. So be careful with it. Response cache, read more if you're not familiar with it, but response cache is essentially cache the whole server response. It's suitable for static information or for information which does not change depending on different users. For example, I can use response cache for this, for the data here. I can use response cache for the open courses, and that's fine. But if these courses are different for different users, I need to implement the caching by using iMemory cache. I need to provide the logic. I need to cache for different users the information. So consider response cache too, but for static information, which is not different for different users, like the trainings here or the webinars that can be used. So memory cache allows you to use caching techniques in your code. You decide the logic behind the cache, and response cache is a fast way to add a cache on the whole response from the server. By using iMemory cache, you can cache only parts of the logic, and with response cache, you can cache everything. You can cache the whole HTML or JSON output. What we can do also is add response compression. If we go to the website and refresh the page, go to the network tab and open softuni.org, we will be able to see whether the server is using compression, and the compression is gzip. So this web server is using response compression. The whole idea behind response compression is that it uses a little bit more CPUs, but the response is a lot smaller than the original data you want to return. So for huge HTML files, for huge CSS files, for huge JavaScript files, you have a huge improvements because this response compression will reduce the network usage, which when you have a lot of users, you will have a lot more room for more users because of network considerations. So response compression will minimize network traffic, which will make your website load faster because the response will be faster, because less kilobytes you have to download, and because the network will be released sooner, you have more room for more users. So response compression adds a little bit CPU overhead, but it's worth it. You can improve the performance of your app up to 2 to 3 times, which is quite a lot. Read more about response compression. It's very easy to add it on a web app. It's something like services add response compression. You may configure it if you like, but the default is app use response compression. It's super simple. Read about it if you haven't used it. Read about the options because it does matter where you add the compression. Because if you add it before static files, all static files will be compressed too. And if you care about that, you will need to add it before it. So add response compression because it's worth it. It's super easy. And you have multiple options. The most popular is gzip. Other thing to consider is you need to minimize exceptions. Exceptions are rare and exceptional. So don't use exceptions as a control flow mechanism. Don't throw exceptions for something that can be done easily with if or else. So minimize exceptions. Exceptions should be really rare. When there is a real problem in your application, don't use them for not found, for example. Somebody tries to find data and you're throwing an exception in your service layer. That's not a good practice. Exceptions are heavy, and a simple no check will be better. So simple no check returning true and false will be better when you have logic which can be written with if else. So exceptions are just like that, exceptional. They should be rare and don't use them for control flow, because a single exception multiplied by tens of thousands of users may have a huge performance impact. Because a single exception is fast, but when we think about the scale of the web server, then you may have a lot of problems. Consider the garbage collection and large objects. When you have large objects, huge objects, consider caching them, because garbage collection for large objects is slow. So consider, if you have a lot of large objects which don't change frequently, consider caching them. You will save a lot from garbage collection. You can also reduce the memory footprint by streaming your data. You need to return a file, stream it from the file system directly. Don't load it into memory first and then send it to the response. Stream it from the file system. If you have a large database call, you can stream that also. Don't load it first into memory and then send it to the response. Use a stream. Of course, that's a more advanced approach, and it makes sense when you have large data and large objects, large files, large response from the database. Don't use it as your everyday approach. Consider using streams only when you have large objects. This way you will save the memory footprint and you will save the garbage collection of that memory, which is huge. Streams are more advanced and you may need to read a little bit before you understand how to stream data from the database, stream a byte array from the database, stream a file from the database. But keep it in mind that you can use it and read about it when you have difficult or large to use objects. Just keep that technique in mind. Last, before we move to the front-end optimizations, is keep long-running tasks outside of the HTTP pipeline. For example, if you need to process a lot of data, you can mark it as data which needs to be processed and have a background job running to constantly check whether you need to process something. So keep out of the HTTP pipeline middleware logic, request response, controller services which are part of the hot path in the HTTP pipeline. All long-running tasks should be separated. Let's consider this. You need to upload an image and you need to resize it. For example, the user can upload 25 images at once. So if you need to resize 25 images, that may take you, depending on the image size of course, but may take you 3 to 4 seconds. That's a lot of time to make the user wait for the result. It's better to just save the images in the file system in raw format, then save to the database that you need to process these 25 images, then return to the client. Your images are being processed. Please try again in 5 minutes, for example. So this way your HTTP pipeline is super fast. The user receives a response super fast and he knows that he needs to wait a bit before he receives a result. Then have a background task, a hosted service in ASP.NET Core. It's very easy to start one, which checks every 5 seconds for new images which needs to be processed and process them separately from the request response pipeline. This way your server will be way more responsive to your users and you are not going to block any CPU because you can control how many images can be processed at the same time. You can always process maximum 3 images concurrently, which will leave a lot of your processors and cores on the server machine free to serve requests and response. If you put long-running tasks on your request response pipeline, your server may starve for resources. So if you have long-running tasks, image processing, video processing, file processing, and so on, and if you need to do that frequently enough, it's not once a month operation, because if it's once a month operation, the user can wait. But if it's everyday process, then if you have a lot of users, your server will starve. Because if a lot of users put a lot of tasks at the same time and they are long running, you will have a bad time. So to conclude, what you need to do is return a response to the user. Thank you for your images or for your video or whatever you're going to process. Please check in 5 minutes for your results, or your images are currently being processed, something like that. But return a result. Save the images in raw format. Mark the images in your database as something that you need to process, and a background task which is controlled can fetch the images one by one and process them. This way you can control how many images can be processed at a time. You can also use external server for processing, but that's more about microservicing, and we're not going to talk about that. So everything about the backend, I covered all common possible problems for bottlenecks. SQL databases, SQL queries, data caching, ORM operations, hotpads, the HTTP pipeline. If nothing works, or if you improved everything and your application is still slow, then it may be a hardware problem. And if it's a hardware problem, you need to upgrade your server hardware. You may improve the RAM, you may improve the hard drives, for example, to install solid state drives. You may improve the increase the CPU numbers. You can improve the hardware, but the hardware can be improved to a certain extent. You can invest in hardware indefinitely. When your hardware uh, is reaching its limits and you can no longer improve it, usually your sys administrators will tell you, well, we don't have any room for improvement in terms of hardware. You need to start scaling horizontally. And scaling horizontally means you need to replicate your databases, for example, like this. If you have two databases and you have one web application, you can read data first from this one, then from this one, but when you write data, you can write to both. So we can make turns which database to use, or you can add even more databases. These should be on separate machines so they don't fight for resources. Because typically web applications make more read requests than write requests. You read from one database at a time, which allows you up to four more operations for reading, but when you write to more of them. You can even split your data. For example, all user profiles which start with the letter A go to this database. All user profiles which start with letter B go to this database. And your app can check, okay, this profile starts from A, I will check that database. But these approaches are very advanced. You need to have a huge application, for example, like Facebook, to start considering splitting your data or something like that. If nothing works from these optimizations, what you can do is start extracting microservices. For example, in one of my projects, it was a monolithic app. We had notifications, and these notifications started to become very slow, super slow. So we tried to optimize them, but they were so much that we couldn't do anything about them. So what we did is we decided to extract a microservice only for these notifications, only for them and nothing else. And we decided to move the old notifications to an archive, and that improved the performance. So extracting microservices is the next step when the hardware cannot be improved and where the software is used as optimally as possibly in terms of these rules I already mentioned. So the next step is extracting microservices, and if microservices and then you need to decide how to scale each microservice. You can add more databases to it, you can split the data in different databases like buckets, and different kind of advanced approaches which believe me, you need to have a huge scale in order to utilize them, but these are available for you to consider. For example, Facebook. If you have Facebook with a lot of user profiles, these profiles should be stored on different databases because that's a lot of profiles. And the app knows, okay, I need to find John. That's J. All the profiles with J are in this database. I'm going to search there. Something like that. Good. Let's take a short 5-minute break and I'm going to continue with front-end optimizations. Again, when the timer hits 5. So we covered everything on the backend, at least all the optimizations you can do without having to do a super advanced approach. But if you hit the problem with super advanced approach, then you probably tried everything I already mentioned. Okay, so for the front end, first things first, images are huge. They probably need optimization. That's a golden rule, because usually if your backend is fine in terms of queries and your HTML and CSS is good enough, the biggest problem will be images in your website or videos, but videos usually are uploaded in one of the major providers like YouTube, Vimeo or something like that, so they have you covered. But with images, images should be scaled. First, if we have images, each image is rendered in a specific dimension. That dimension comes from the design, so you will know. Let me move, not here but here. You will know how big is the actual image. You will see that this is 300 pixels. So don't return an image which is too huge. For example, this is a problem here. My image, if I go to softuni.org / the image, well, that's another image for some reason. Okay, let me try to find it here. Five beginner mistakes, that's this one. So let's see the image preview. We can see that the image is 1200 pixels and it's rendered on 300 pixels square, and that's a bad example currently, because if I have a fast internet, I'm not going to see any issue here. But if somebody is using a mobile internet or is not having a super fast optic internet at home, this may be a problem. So optimize images, because if not only because of the internet, but because your web page will load faster if your images are improved. For example, if I have 4 images here which require 1 megabyte in total, if I lower their image size, I will have something like 100 kilobytes, which is a 10 times improvement. The browser will render them faster and they will come from the network faster. So this is important. Optimize images. And sometimes you may need to render the same image on multiple pages, on multiple squares. For example, here the square is 500 pixels and here the square was 300 pixels. The best approach, if we want to be as optimal as possible, is to resize the image for every square you need and then fetch the specific image size. So if you have a smaller the same image used in 2 squares, one small and one big, like here, then provide 2 versions of the image. Don't make the administrator uploading 2 images. That's operational cost. That's not a good solution. But make every image and resize it when the administrator uploads it. So when an admin uploads this image, we can resize it by using a background task and provide 2 different versions of this image. This way, the image will be as optimal as possible, because currently we're having too big images for our needs, and that's not optimal in terms of network, in terms of browser rendering, and so on. So make sure you scale your images. Other thing you can do, you can use the so-called sprites. That means you can return all images for a page in a single image, then by using CSS to render specific parts of the whole image. This way you will make a single network call for 10 images and the end user won't understand anything. So the important thing here is first use a lossless format, for example PNG. Consider the quality to be web optimal, so don't use pictures and images which are perfect quality. Reduce it a bit, but reduce it to a point where the end user won't see the difference. Because if you have 100% quality and if you have 70% quality, the end user won't see the difference. 70 is a perfect number for quality percentage. And so the end user won't see the difference, but you will save 30% of the image size, or something similar to 30%. Resize images, scale them to the squares you need, and if you need the image multiple times, resize it multiple times. Just store different versions. If you have a lot of images, consider using a CDN. Return these images from a CDN. You will save a lot of network calls to your own main server, which can be used to serve something else, for example, queries and data. You can also specify image dimensions in the HTML with width and height. The HTML allows you to provide the image tag width and height. You will save browser rendering, because if you don't provide image size, the browser need to render that image twice, and in terms of front-end visualization, that is huge. It's better to have one rendering of the page instead of two, because if you don't specify the image width, like I believe we did here, we didn't do that. We only have out, but we may have image with somewhere stated in the CSS. Nevertheless, the whole idea here is to specify image dimensions, because if the browser knows the image dimensions before rendering the image, the browser will store this square for the image and won't need to re-render it when the image returns. But if the browser doesn't know the image size, the browser doesn't know how big square it will need. It doesn't know what to include here, and the browser will need to fetch the image, and when the image is returned, it will need to specify to render the page with the images. So you may have double rendering from the browser, which again is taking some time. You may not specify the HTML tags, but the important thing is that the browser needs to have the width of the image either from the CSS or from the HTML. Here, the browser knows that the image is maximum width of the container, and the container has a fixed size. So by having that information, the browser will know not to re-render the image. So we're doing it right. The only thing we are not doing right currently is serving larger images than we need. So in terms of images, optimizing images in terms of quality, 70% is good enough. You may use 80. Using a CDN, scaled images, and make sure the browser knows the image size before rendering it. by either CSS or HTML. Besides images, you can use browser caching. Browser caching is by default in ASP.NET Core, all static files have cache, so that's more than enough. But you can cache the browser and not cache the images and all the assets in browser, so that if the user gets to the page a second time, it won't fetch the data again. So the browser also has caching mechanism and you should use it. What I mean by caching is, let's check some image. For example, this JPEG here. We can see that the browser uses that from memory cache. Because the server sets some expires headers, some cache headers, add tag expires, I suggest you read a little bit more about browser caching and what kind of headers you can add to the cache, to the response, so that the browser will cache it. If I go to JavaScript, I can see that I already have the JavaScript, so again it's from the memory cache. This one too. Almost everything in the browser is from the cache. This is why the whole page loads faster. If I disable the cache, it should render a little bit slower. Because now everything should be fetched without, well, I disabled the cache, but it still uses the cache. Let's try that again. Now I can see that it's not using the cache. Yep, now it rendered the whole page from the server. So the thing is, learn about HTTP caching and how the browser can use that. Cache everything which is CSS, JavaScript, image, and so on. By default, ASP.NET does that for you, but make sure you validate that it's working correctly. If I fetch the page again, it should be from this cache. That's important because every time a user visits your site for the second or third time, this cache will save you a lot of network calls and will save you a lot of server resources which can be used for other users. So that's also important. Cache everything you can cache on the front end. Images, CSS, JavaScript, and so on. And make sure you give an option to update the JavaScript, because if the user caches the JavaScript and you update it without releasing the cache, he will have an outdated version. So that's important too. By default, ASP.NET allows you to cache everything which is static, which is good, and also allows you to have a version. This, for example, this JS site JS script will be cached, but every time you provide a new version, this attribute here, ASP append version, will refresh the browser cache. That's important because otherwise you will update the site JS file, but the browser will not fetch the new version and your users will not see anything new. So this ASP append version is important. So you need to learn HTTP caching. That's the important part, to see how it works. Then make sure you use the ASP.NET features. The ASP.NET features are this one here, which allows you to refresh the cache if you change the file, so that the user can fetch from the server the new file. And if you use the default static files middleware, it will cache everything for you. Good. Next, JavaScript and CSS. You should know that already, that's a common fact. You should minify and bundle JavaScript and CSS. But make sure you do it for each page. Because let's consider this. If we load 3 megabytes of JavaScript on the home page, that will reduce the home page responsiveness. It will be slower, it will be very... the thing is, we're going to have 3 megabytes of JavaScript on the home page, which will be cached, and that's okay, because the second time the user visits the page, this JavaScript files will be cached. And if the user tries to navigate somewhere, these JavaScript files again will be cached. But having a huge file will reduce the responsiveness of your homepage. So the best way to improve the front end is to have a bundle for all your common JavaScript files. So all JavaScript files that are loaded directly on the homepage, they should be bundled like this, the site CSS. These are all the common JavaScript files. Every single page needs them. For example, in jQuery 2, Bootstrap, jQuery, all of these should be bundled into a single file. Then for each separate page, include a section scripts. For example, on the home page, include a section scripts and add the script here. So the best way to have maximum performance is to have one CSS file for each for the common things, one JavaScript file for the common things which are loaded on every page, and then for each separate page add additional bundled JavaScript. Don't load too many scripts, because that means you will need to make a lot of network calls, but don't load a single JavaScript file for the whole application, because that means the initial request for that JavaScript will be huge. So minify and bundle, but do it for each page. Don't include scripts you don't need. We had a web page which loaded 3 megabytes of JavaScript for a single button, because that JavaScript was used on different pages. But this made our home page loading for super huge amount of time, 3 to 4 seconds, because the browser needed to fetch the JavaScript and then needed to execute the JavaScript. And when we had only 50 lines of code needed for that page, that was unnecessary execution. It slowed down our page a lot. So the best tip here is bundle and minify the JavaScript, but do it for each page. Include the commons and then include for each page a separate bundle. That's the fastest way you can do. Always put CSS at the top of the page, for the reason that if your CSS is loaded first, then the user will see beautiful content right away. And if you put the CSS at the bottom, then you have a problem, because your web page will flicker a bit with the empty HTML, and then it will be re-rendered because of the new CSS which was loaded. So the CSS should be always put on top, like here in the layout. It should be always put on top. Here it is. And the scripts should be put at the bottom, because not because you improve anything in terms of performance, because the browser still needs to load the JavaScript and still needs to execute it, but the user will think that your site is loading faster, because if you put script tags in the in the middle of the page or on the head, before the page, the browser will first execute the JavaScript and then will start rendering. And if the JavaScript is at the bottom of the page, then the browser will render the HTML, and then while the user looks around, it will execute the JavaScript. And that's this way the user will think that your website is faster. Not because it will load faster, but because the user sees more information before the JavaScript is executed. Then the last thing about CSS or JavaScript is if you have small CSS or JavaScript files, inline them. If you have 3 lines, don't include these 3 lines in a separate file. That's one extra network call. Inline them. If you have small amount of JavaScript, it's better to inline it into the page, because extra script file means extra network call, which is a little bit too much. Some advanced front-end optimizations is reduce DNS resolving by serving everything from less domains. For example, you may have a single domain and a load balancer for that domain, and then everything else should come from CDNs. This means that every single most of your requests will come from a single DNS, and that's a little bit of an improvement. Of course, that's a minor thing to consider, and it will be optimal only for new users, because old users already resolved the DNS. Use cookie-free domains for assets that do not need cookies. For example, all JavaScript files, all CSS files, all images should be on a domain which does not need a cookie. When you store a cookie in your browser, that cookie is for a specific domain, and when you make a request for the domain, the cookie is sent to, which increases the network load. If you have a cookie which is sent to the images endpoint and the images don't need the cookie, you're essentially making your request be bigger than it needs to be. So if you move all the assets to a CDN which doesn't require a cookie, you're good to go. That's the best scenario, because if the images are coming, for example, like here, all the images come from the same server, and if we have a cookie set here, we have a lot of cookies. This means that all these cookies will be sent when the images are fetched, and that's not optimal because the network will suffer. We're going to send 30 kilobytes more than we need, and 30 kilobytes may not sound a lot, but consider having 10,000 users. Then 10,000 users multiplied by 30 kilobytes, it becomes a lot of megabytes, and these megabytes can be saved, and these megabytes in network can be used for even more users. So even these tiny improvements make a difference when we talk about scale. Every single image which is larger than it needs to be, every single request which is larger than it needs to be, is additional kilobytes over the network. And when we consider that, okay, the site is fast, but when we consider the scale, that if we have a lot of users, that will have a lot of additional network calls, a lot of additional network traffic, which will require more resources on our server, and so on. Apps like Amazon or Facebook optimize every single kilobyte, because million users, if 1 million users add a single kilobyte, that's a lot of traffic and performance improvement for their website. So it's very important to consider even the small improvements because they work very well on scale. Of course, don't over optimize every image, every network call, and so on. But if you want to improve your performance because your app scaled and a lot of users are starting to using it, then consider even the smaller optimization paths because they make a difference on a huge scale. So even if we have 20 kilobytes of cookies, these 20 kilobytes will save us a lot of resources when we have a lot of users. So consider removing cookies for assets that don't need them, like images, for example, CSS or JavaScript. The easiest solution here is just move all static resources to a CDN and load them from there. This way the cookies for your application won't be sent to the CDN because cookies are per domain. Other advanced front-end optimizations are AJAX requests to be GET requests. You combine headers and data, and that saves a little bit of space. That's super advanced, but you can do it. Make fewer HTTP requests if possible. For example, combine images, combine scripts, combine CSS. I already covered that. That's important. And do not put too many things in cookies. For example, if you use cookie-based temp data, because if your cookies are getting bigger, every request will have a lot more information in it, and again, that doesn't scale. For all the front-end optimizations, you can use the site GTmetrix. GTmetrix is a cool website which allows you to analyze a website for front-end optimizations. Keep in mind that these tools, Google also has a similar tool, these tools call your website from a far location. For example, our softtuning.org website is the server is located in Bulgaria, which is quite far from Canada. So if I try to assert my web page from GTmetrix, it will say that the site loaded for 8 seconds, but that's not completely correct because it clearly doesn't load for 8 seconds. So keep that in mind. That thing here is not important. That's not important because if your audience is not in Canada, you don't care about that. If your audience is in Bulgaria and your server is in Bulgarian, it's fine. Then it's fine. But if your audience is in Canada and your server is in Bulgaria, you have 8 seconds response time. Then you need to move your servers or use or make more servers. For example, one in America, one in Europe, and so on. Like video games. Video games usually have different servers. One for Europe, one for Asia, one for America, and so on. Because and you need to play on the server which is closer to you, because that way you have better speed. The same is here. So don't consider this thing, but consider all the suggested improvements here. For example, for our page, I already said that our images are not scaled, but we can see that it suggests to scale images because we can improve our image from 1000 to 30, which is 93% reduction. That's quite a lot. 500 kilobytes is quite a lot. When we consider that the whole page is 1 megabyte and a half, 500 kilobytes is like 30% of the whole homepage just by improving the scaled images. So that's important. And we already knew that our website doesn't implement that optimization. Then use browser caching. All these assets can be cached. Look, we have a lot of assets that are not cached. Some SVG files, some the favicon, some CSS files, some JavaScript files. These are not cached. And if we cache that, we can uh, we can save a lot of network calls. So these two recommendations are with high priority according to these two, so we need to do that when we hit a performance problem. Then we have unminified JavaScript here and there. We can see that it's not that much. We can see that some of our assets are not compressed, and we can see that we can improve 23 kilobytes, 61% reduction. Again, 23 kilobytes may not sound a lot, but consider the site on scale. If we have super many users, for example, tens of thousands users, because currently this website is not that advertised and the user base is not huge, so we don't need to implement all of these recommendations, but if we hit a huge scale, we need to improve that, because 23 kilobytes for 10,000 of users is a lot, and we can improve the performance of our backend by improving the performance of our frontend, because if our frontend is smaller, the backend will have more resources and room to serve even more requests, because it won't need to serve large requests. So that's also important. So we can see that the site is not that bad. It has a lot of the recommendations are followed, and we can improve the images and the browser caching. Of course, we can improve it with 30%, which is a lot, but still the website currently is performing very well. So you can use this tool to improve the performance of your website by following these advices here. I already mentioned the most important parts in during the lecture, but you can use the tool so that you don't need to remember them. I had a project which was improved with more than 70% from with more than 70% when I optimized everything in this list. Here are another suggestions. So here and here you can see different suggestions, and if you follow the advice here and improve everything, you will see huge improvement. Trust me, huge improvement. You will see a lot of, you may improve your site with 20 or more percent depending on your current grade. So make sure to validate all your apps with this tool, and that will improve the front end, and by improving the front end you will improve the back end throughput also. So pretty much that's it. Improve the front end, which will improve the back end. Then on demand, try improving different aspects of your web page, queries, ORMs, and so on. So if you have questions, you may ask them in the YouTube chat. Of course, now it's August, it's a vacation month, so most people will watch this video on a recording. So if you have any questions or any advice or any comments, you can ask them on the Facebook group, which is the Coded Up Facebook group, or you can ask them down below in the comments. So thank you for watching with me. I hope you really like this lecture. I wanted to give a lot of examples from my experience, and I believe I managed to do so. Thank you guys for the support, and I'm going to see you in the next video. Bye for now.